6, which is transformations of functions. It has several different objectives in this section, and the first one is just talking about the graphs of the common functions. I'm not going to draw those for you over again because they're in a table in the book. But these are the common functions that we'll be using throughout this first semester while we do this algebra part, and then we'll do a little bit with them in the the trig portion, but not a whole lot. That's on page 205. And it's table 1.3. So you can look there and you can kind of see most of these are probably familiar to you from Algebra 2. Very little of it is actually new. We've actually worked with every single one of these functions before. So if you will look there, you can see its domain, its range, whether it's decreasing or increasing, and whether it's an even or an odd function. So they went ahead and talked about all the vocabulary that we've had already in this table. Okay. So objective 2 is where we're actually going to start the lesson today. These are vertical shifts. And again, all of this is stuff that we did in Algebra 2. Well, you and I didn't do it, but y'all have done it in Algebra 2. A vertical shift, remember, just takes the graph of the parent function, the one you started with, and a vertical shift moves it up or down. And so the notation for a vertical shift is that f of x is equal to your function. Okay, so that could be, equal to x for a linear function, or quadratic, it could be x squared. It's just your function. It's a notation we're going to say for the function that we're talking about, this particular function. So on the vertical shift, if you have y is equal to f of x plus some c, where c is a positive number, then that moves the graph, the parent function that you started with, whatever it was, up that many units. And then y equal f of x minus c will move it down, same number of units. And so what's the important thing about where the number is that's being added or subtracted? Does anybody remember? It's what it does to the graph. And so if it's a vertical shift, it actually moves it, the number is actually on the outside of the function. Does everybody understand what I mean by the outside of the function? So on checkpoint 1, the function that we're actually going to talk about is the absolute value of x. And what they want us to do is come up with the graph of the absolute value of x minus 4. So you notice the minus 4 is totally outside the absolute value marks. So it's outside the function. So what that's going to do is, since you know what the absolute value function looks like, I hope, anybody got a verbal description of it for me? Kind of a V. I like wedge, I guess. Anyway, all right. So I'm going to take that whole graph and I'm going to move it down 4 units. Now, the way you move it down 4 units is you take the y coordinates and you actually subtract 4 from every single one of them, right? This is a big idea when we get to trig, y'all. So you need to make sure you got this idea going on right now while this is stuff that's familiar to you, because we're going to get new graphs and we're going to do the exact same thing. So if you think about that, the parent function, the points that you have here are -2, +2, -1, 1, 0, 0, 1, 1, and 2, 2, right? So if you wanted to do this by coordinates, then you aren't changing your x coordinates at all, right? If the number that you're adding or subtracting is outside the function, I'm not changing x at all. I just changed the y value. So you can take all the old y values and subtract 4 from them. And that would give you very graphical way of figuring out what you were supposed to do. So instead of being at 0, 0, I've moved down to 4, so I've got this point 0, negative 4. And then at negative 1, I'm at negative 3. And at negative 2, I'm at negative 2. At positive 1, I'm at negative 3. And at positive 2, I'm at negative 2. So my overall effect was that I moved the entire graph down 4 units. Okay? So the next objective that's in here is the one that talks about horizontal shifts. Horizontal shifts, where does the number go? Inside the function. So we'll be saying that y is equal to f of x plus c, and y is equal to f of x minus c. Now, horizontal shifts mean I'm moving the graph which way? Left and right. So that's right. So if it's x plus c, then we moved it left. And if it's x minus c, then we moved it right, that number of units. Now, what did I do to the coordinates? Which coordinate did I change this time, x or y? The x. And I know this says x plus c in the parentheses, but what did I actually do to the x coordinates? You have to subtract that amount from the x coordinate. So if you're working with the coordinates, remember if the number is inside the parentheses, you always do the opposite operation. Okay? So checkpoint 2 wants us to take this graph f of x equal to the square root of x and get from it the g of x function, which is the square root of x minus 4. So the minus 4 is inside the function, right, because the square root extends all the way over it. You have to be careful on the square roots to make sure that you can see where the end of the square root bar is to tell if it's affecting the x coordinates or the y coordinates. So if I do the parent function of f of x, then, you know, my points that I might have for x and y, I've got 0, 0, right, because when x is 0, y is 0. When x is 1, y is 1. And the next one I'm going to use is not 2, because I don't like the square root of 2 trying to plot it, right? So I'm going to use, what's the next one? What's it? 4. Next perfect square is 4, and the square root is 2. And that continues out. Okay? When I do this function, if I wanted to do coordinates, then like we said, what we're going to do is we're going to take the x coordinates and we're going to add 4 to it. So instead of 0, I'll be at 4, 0. And instead of 1, I'll be at 5, 1. And instead of 4, I'll be at 8. Okay? And so, let's see if I can actually draw a graph big enough to be able to see all that. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. All right. So at 4, I'm at 0. And 5, I'm at 1. And at 8, I'm at 2. So I moved it to the right 4 units. Okay, so that's how you can take your coordinates from your original your original graph, and move it. Now, I know y'all are sitting there thinking, I can just put that in my calculator, and I don't know why she's doing this, but there are some of the work on the homework where they don't actually give you a familiar graph. They give you just one that they've drawn a strange-looking function to, and they tell you to do f of x plus 4, or f of x minus 4. So you've got to use the coordinates on the original graph to be able to come up with what the transformation will look like. Okay? Y'all good? Why y'all dying? I got it too hot in here? All right, the next objective talks about reflections. So objective 4 is reflections. Does anybody remember what causes the graph to be reflected? Mirrors, okay. as far as numbers in an equation? Negatives. So if y is equal to a negative f of x, what am I changing? So which coordinate is changing signs? The y. Anytime it's outside the parentheses, I'm affecting y. Now, I know what y'all were thinking. Since I'm changing the y value, which axis am I reflecting across? The x-axis. So y'all were trying to answer a different question that I hadn't asked yet. This is a reflection across the x-axis. Okay, and if I have y is equal to f of negative x, then that's changing the sign of the x value. And if I'm changing from a positive to a negative x or negative to a positive x, what am I reflecting across? The y-axis. Good. All right. So, checkpoint 4 wants us to use the graph f of x equal the absolute value of x to get g of x then the opposite of the absolute value of x. So, the absolute value of x, if we came up with a table, we'd have -2, -1, 0, 1, 2, 2, 1, 0, 1, 2, right? Because the absolute value just makes it positive. Okay. Now, which of the coordinates am I actually changing? The y coordinates. So my x coordinates stay the same, but now all my y coordinates are going to be negative except for 0, which is just 0. So 0 is a real number, yes, just not positive or negative. And so as you can see, the end result graphically is that now the thing has been reflected across the x-axis and it's pointing down instead of up. Okay. The next objective is the one that talks about vertical stretching and shrinking. Okay. All right. So, remember that stretching and shrinking happen the same way. It's by multiplying by a number, right? Instead of adding or subtracting, and I'm multiplying by a positive number because the negative sign, the only thing it does is the reflection part. Okay, so I'm talking about the positive part of the number, and if c is a number that's greater than 1, then, remember, I'm taking the y and multiplying it by a number bigger than 1. So what's going to happen to y? It's going to get bigger, which is going to stretch vertically the graph, right? So this is a vertical stretch. So y equals c times f of x is a vertical stretch. And the way you figure it out, or the way you try to figure what it's going to look like, is you take each y coordinate and multiply by c. Now, if c is a number between 0 and 1, then I'm talking about a fraction, right? I'm talking about like a half. So if I take y and I multiply it by a half, what actually happened to the value of y? It decreases. So I'm actually doing a shrink. I'm shrinking the graph vertically. So y equals c times f of x then, in that case, is a vertical shrink. or compression was the word we used last year. But you still do it the same way, by taking each y coordinate that you have, and then you multiply it by c. It's just that you're multiplying by a fraction, so the y's are getting smaller. Not as hard as what it seemed like before, right? Not a hard thing at all. And then we have the same thing for horizontal stretches and shrinks. Except this time, where are we putting the C? Oh, let's see, and C we're still talking about C being a positive number, and if C is greater than 1. So we're going to have that y is equal to f of c times x. Okay, so when it's horizontal, remember it's inside the parentheses because I'm affecting the x coordinate, right? So what is this going to do? Because remember, if I'm inside the parentheses, what kind of operation do I use? It's the opposite. And so what I'm going to be doing is I'm going to be dividing each x-coordinate by c. So the x-coordinates are going to get smaller. So what's happening when c is larger than 1? It's a shrink. So this is a horizontal shrink. Because I'm going to take each x-coordinate and divide by c. And since c is a number bigger than 1, it's going to make the value of x smaller. Now, when c is between 0 and 1, and I do this to it, then I'm still dividing, but I'm dividing by a fraction, which is like multiplying by its reciprocal. So it's actually going to increase the x value. So it's a horizontal stretch. So we're going to take each x-coordinate and divide by c again. Okay. Now, in case you're worried about remembering all that stuff, all of those transformations are summarized on page 213 in table 1.4. So all that's written for you again there, so you can look at it. But now there is a certain sequence that you have to use when you're doing these transformations. So this is the order that you have to do the transformations, and this is objective 7. Okay, so 1, you do any horizontal shift. Secondly, you do any stretching or shrinking. Third, you do any reflection. And fourth and last, you do vertical shifts. Okay, so let's try that. Checkpoint 8 wants us to use this figure f of x that we've got on a previous page. And we're going to graph y is equal to negative 1/3 f of x plus 1 minus 2. Okay. And our f of x that it's wanting us to use is this one that's right here. And at -4, I got a point. And it comes up to -2, +4. And then it goes back down to this point 0, 0. So it's got that nice curve right there. And then from there I go to 2, -2 with a line. And then I go back to 4, 0 with another piece of a line. So like I say, sometimes on the homework it's going to just be a graph. It's not an equation, so you can't just plug this in your calculator. So, based on the order of operations that I gave you, or order of transformations I gave you, is there a horizontal shift? Is there a number added or subtracted inside the parentheses? Yes. I need to shift it to the left 1 unit. Okay, so I'm going to take all those points that I have there now. And if you need to, write the points down in a table and actually physically do the math to it, the adding and subtracting or multiplying and dividing. But if I'm moving left, then that point that was at -4, 0 now needs to be at -5, 0. And the point that was at -2, +4 now needs to be at -3, +4. And the point that was at 0, 0 needs to be at -1, 0. And the point that was at 2, -2 needs to be at 1, -2. And the point that was at 4, 0 needs to be at 3, 0. Okay, so there's the first piece, or the first step. Okay, now, no, I'm just showing you how it works. Remember, I teach in steps. You can skip all the steps you want. Okay, and so then according to my order of transformations, the next thing I need to do is any stretching or shrinking. Okay, so is there anything multiplied here? Okay, there's a 1/3 and it needs to be multiplied by what values? The y's, because it's outside the thing. So if I do the 1/3 thing, well, this y value here is 0. Is it going to change? Because 0 times anything is still just 0. But the 4 times 1/3 is going to be 4/3, which is just a little bit more than 1 1/3, right? I mean, it's 1 1/3. I don't know why I said a little bit more. It's exactly 1 1/3 because it's 4 times 1/3 is 4/3. And then the next point that's at 0 will stay at 0. Now the next point that was at 1, -2, when I multiply it by 1/3, is going to be at 2/3. So it'll be about right there. And then the point that was at 3, 0 will stay at 0. So we definitely shrunk it, huh? Vertical shrink. Now, the next thing that we were supposed to do is do what? Any reflection? Okay, so what do I need to do? Where is the reflection happening? To the y coordinates. Okay, so the 0 will stay the same. But instead of at 3 it being up at 1 1/3, it'll be down at -1 1/3. The 0 will stay the same. But at 1, instead of it being down to 2/3, I'll go up to 2/3. And at 3, I'll still be at 0. So I've got the rounded part, and then I got the little. Okay. And then the last thing it says I should always do is the vertical up and down. And so my last step, which is my, let's look, we're subtracting 2. So my very last graph, which is my final graph, is I'm going to take that last picture and I'm going to move it down to units. So the 5, 0 will be at 5, -2. And the 3 and the negative 1.5 will be at 3.5 or 3 1/3. Yeah, because when you add 2 to 1 1/3, you get 3 1/3. Okay, and then when I add the negative 2 to, or the subtract 2 from the 0 here, I'm back at negative 2. And then at 1, I was supposed to be at 2/3. So if I subtract 2 from 2/3, I'm at 1 1/3, right? And then 0, and I'm down at negative 2 again. So, okay. Like I say, you may want to do the arithmetic over to the side instead of trying to do it in your head. Okay. Any questions about how to do transformations or the sequence in which that you have to do them? This right here is a big idea for us next semester, I'm telling you. Okay? All right. That's all there is to this assignment. This lesson. You can get started on your assignment.